Good morning, everyone. Hopefully everyone's logged in fine, and it's really nice to virtually see everyone for what is the launch event for Camera 2.0. So I'm just going to navigate some technical things, and I'm going to share my screen. So hopefully everyone can see that now. Great. So really thank you everyone for coming along to this this launch event. My name is Professor Darren Koska, and I'm the director of CAMERA. And if you don't know what CAMERA stands for, it's the Center for the Analysis of Motion, Entertainment Research and Applications. Now, some people might be mildly confused because wasn't there already a launch event for CAMERA in 2015, which many of you may have attended, and some of our speakers certainly spoke at. So, and this was physically right back when we could all be in the same room. So this is a very different kind of launch event. So what is actually the launch event about today? Well, CAMERA was initially funded for 5 years by the EPSRC and the AHRC, which are the primary science and arts research funders in the UK. And there were six research centres funded in total. So we're one of six. And these were all competitively awarded to be flagships for the EPSRC's digital economy research theme. And so we had this initial funding for 5 years, and then in 2019 we started working really hard on trying to acquire the next 5 years of funding. And this was then a long process where we reached out to multiple partners and different people, some of whom we'd already been working with, some whom were new partners, and we were trying to get people together to work with us on the next stage of the journey. And after lots of hard work and several competitive rounds, we finally secured a further 5 years of funding from EPSRC, and that was at the end of 2019. And it takes a long time for these things to get started, and now we're kind of at the starting point now for the next 5 years. And that brings us on today, which is kind of our relaunch event. And this serves multiple purposes, if you like. It's a short introduction or reintroduction to CAMERA and how it was started. We're going to look back at the highlights some highlights from the last 5 years. We're going to look at where we are today, what the next 5 years will bring. So we've got roughly an hour, and so you're going to hear from me for the first 10 minutes or so, and then we've got a range of speakers from academia and industry, and they're going to give presentations and talk to you for around 15 minutes around each of CAMERA's themes, which I'll talk about more in a moment. And then at the end of it, you're going to come back to me, and then we're going to wrap up, and there's going to be a short Q&A. So you can use the Q&A function if you like, and start putting questions in there. Okay, so what is CAMERA, and how did CAMERA get started? So, as I said, CAMERA was one of 6 digital economy research centres funded in September 2015 by EPSRC, and we managed to win an award of around £5 million, and we had matching contributions from industry. And back in 2015, it was really exciting. You know, it felt like a startup. Essentially, we started entirely from scratch with a small but talented group of academics and students and postdocs, as well as a small but very supportive group of external partners. And someone said to me the other day, you know, we used to have our CAMERA meetings our weekly meetings all in the same room. You know, we could all fit in the same room. But you know, fast forward to today, and you know, we can't really do that anymore. We have over 60 people in the research centre, not including external partners, and we're growing. I couldn't probably give you a definitive figure of how big the centre or how many people are affiliated, but it's you know, it's rapidly expanded in the number of postdoc, PhDs, and academics. And over the last 5 years of the journey, we've achieved many things together. We've published many academic papers. I think we have over 200 academic papers which CAMERA has published. And we're a multidisciplinary research center, so we do research across 3 different themes, and these are creative science and technology, human performance enhancement, and digital health and assistive technology. I'll talk more about these as we go on. So so this 200 papers, they're focused in not just one area, but they cut across, if you like, these 3 different themes. So that's the idea of camera. And in addition to the research themes, one of the main things camera is about is impact, and we've created a unique impact-driven model that not only helps deliver commercial projects, but uses these commercial projects as a vehicle for our research. And this helps us to close the gap between academic prototyping and use of research in the real world. And there are many projects that I'm really proud of from the team over the last 5 years. And you're going to hear about a lot of these projects and a lot of research from the speakers after me. But just to pick a few out, we delivered motion capture for Aardman's first video game, which was BAFTA nominated, 1111 Memories Retold. We've created a digital geisha for a virtual reality opera experience, complete with football nets to simulate clothing, courtesy of our innovative studio team. 2 others, which I think really embody what I think this impact model of camera is about, and what we love to do in camera in terms of impact. 2 projects called Cosmos Within Us and Is Anna Okay? And in both projects, the team incorporated our own in-house tools for rigging and motion capture based on papers that we published and done research on. So this is, an entire pipeline we put together, published papers, and then delivered projects on, which is entirely what we want to do at camera. And I think they demonstrate what we continually strive to achieve in camera, which is impact from research. But camera isn't just about the creative industries. It's also about research. It's primarily about research which cuts across multiple areas. So we like to take ideas and solutions from one area and maximize impact in other areas. And something that I'm really proud of is in our center is how we've worked together across our 3 themes during the last 5 years. So, we've pioneered the development of life-changing personalized lower limb prosthetics. We've combined motion capture with exercise classes to help fall prevention. And we've also developed Markerless human performance capture systems for elite sport and for injury prevention. And you're going to hear more about these projects in the next speakers. And going forward, the technology we've developed for human digitization, modeling, the analysis of motion, and their applications across multiple domains are going to be central to what camera will be doing. And that brings us to today. So where are we now? We have we've grown from a very small group of people to a thriving research center that continues to grow and evolve. And over the next 5 years, some of these things will continue on. Some of the projects, we're going to be building on momentum that we have in core areas. But on the other hand, it certainly is not going to be business as usual. We're evolving, and we have big plans already in motion that are going to take us in new directions and create new avenues for impact. So let's go through what we can expect then in camera 2. So first thing is that we're sticking with our 3 main themes. So we didn't want to just think up 3 new themes for camera 2. That part we didn't think was broken, so let's not fix it. So we've got creative science and technology, we've got human performance enhancement, and we have digital health and assistive technology. So they're still going to be camera's themes. We're also sticking to the core tenets, if you like, of camera. So we are an interdisciplinary research centre. We like to work on projects in the middle disciplines, but we also like to tackle problems which are multidisciplinary, which require multiple disciplines to achieve. And being a multidisciplinary research centre, all the work we do should have the potential for impact across multiple areas. So we try and pick projects which are useful across multiple themes, okay, and can have impact in multiple themes. And in order to achieve this in the best way we can, we will not only be continuing to base fund and build on existing successful strands of work, such as our cross-cutting motion analysis research, which, as well as providing the foundation of our avatar animation work, is fast moving towards deployment with coaches and clinical users. But we will be funding new projects with partners through different waves of funding across our 3 themes. And this can include postdoctoral research time, engineering time, PhD studentships, and these may be standalone or matched by partners. And I'll talk more about that in a moment as we go forward. And finally, just on this part, a significant growth and changes in Canberra as a research centre also mean that the breadth and the scale of our activities with partners and the community and impact in general is going to change massively. So what I'd like to do now is just briefly expand on then these exciting changes and dig a little bit deeper into these and what they're going to look like. So to start with, we have grown our partner base from 6 initial partners at the application stage of Camera 1 to 25 partners providing us with letters of support and partnership for Camera 2. And this includes a truly amazing range of talent from video game companies, visual effects companies, to elite sports teams and healthcare providers, to world-leading research centres. In total, the support from partner contributions were projected at around £4 million towards technical and research time, access to things like clinical populations and elite athletes, support for PhDs, software access, data access, hardware, co-organisation of workshops, sandpits, visits and travel. And we're also really grateful that the University of Bath see us as a strategic asset, and we received around £2 million in support from the University of Bath, which we're immensely grateful for. So what does the vision for partner relationship look like going forward? So, if people want to work with us, and it's not restricted just for these partners, right? I want to emphasize that we're an open door, which I'll talk a little bit more in a moment. Working with others, having partnerships. Of course, we will look at things like how we co-fund and collaborate on projects. We want to create new research, engineering, technologies which help people, creative experiences. And I think one of the things we're shifting to in terms of our impact is wanting to be enablers of others. So we want to enable great work, not just between us and partners. It's not always a camera partner relationship. We want to build bridges and networks between other partners and create new partnerships which may not even include us. So we want to become essentially a catalyst just for great work, right, in these areas. And we want to do this by facilitating and helping financially support workshops, networking events and sandpits, essentially creating a community for discussing research ideas and fostering connections that can result in new projects. So this is going to be a major part of what we do in Camera. Another big change in Camera, and one of the things which is going to help us achieve this, is our facilities and the scale of the team that we now have and we're going to have to help deliver research and commercial projects. So up until now, our studio has primarily been based at the University of Bath, and some people have visited it, or some people have seen pictures of it before. However, with additional funding from the EU feeding into Camera, we've been building a new facility at the Bottle Yard Studios, which is in Bristol. So this is the largest film and TV studio in the region, and also home to, not only home to visual effects companies such as Axes, but also, prop departments, rigging departments, everything you'd expect to be in a essentially a production studio. So it's a really great ecosystem. And lots of different productions come in and out of the studio, and this is really going to put us at the heart of kind of production in the region, and place us in the heart of UK production. And it's a work in progress. Like we've got a lot of work to do. We've started putting the hard work in to make this into the the studio that we have in our vision. And as you can see, we've already, from some of the pictures, we've already been busy setting up a curious looking stage that kind of looks like a Borg cube, and we've been building offices at the Bottle Yard as well. And so the facility is 600 square meters, and it's not only going to host a new motion capture stage, which is it's actually big enough to fit a tennis court, and we're absolutely going to be like motion capturing sport and things like tennis in this volume, but we're also putting in new facilities as well. So, things like volumetric capture, and, really trying to build really cutting edge human digitization technologies. So watch this space. So, and, with the facility, we're not only going to engage in new research activities and increase our commitment, but, we're going to be doing some other things as well. So coming back to the community stuff I was talking about, the community outreach, what we're going to be doing, with the help of the EU funding and the camera funding and the camera team, we're committing to delivering over 100 12-hour assists to companies in the Southwest region. So we're basically opening up our facilities and our research expertise to others. And we've already been engaging in this kind of activity at the Bath studio, the Green studio. But with our Bristol studio, we're going to be expanding not just the amount of assistance we can give and access to our technology, but also the type of technologies and research tools which are available. And we're also offering free workshops, from everything to motion capture to creating digital avatars to using volumetric capture. We've already delivered our first workshop in this area last month. And this is not just, this is not only open to, this is not only for the Southwest region, and it's not only open to partners. If you're not already engaged with us, then get in touch, and we can figure out ways of engaging to use our technologies and our facilities. Our mission is really to democratize and open access to things wherever we can. I also want to acknowledge other exciting developments in the region, like Camera is going to be a part of. The Southwest region is a very exciting place right now for creative industries and for other areas. As part of a large consortium with others in the region, we helped secure over 30 million in funding for the Southwest for the creative industries. The project is called My World, and it's led by Professor Dave Bull from the University of Bristol. And and basically, the entire project is going to invest in fundamental research, industry training, and infrastructure over the next 5 years. So this is also going to be feeding into Camera research and facilities. Okay, so apologies, I'm like a slightly overrun on the original 10-15 minutes, very slightly, but just wrapping up then, when you combine all these things together, the things I've talked about, the amazing people, the partners and facilities, the other great things which are happening in the digital economy landscape, as well as, the two amazing doctoral training centers we have at Bath, or, the Center for Digital Entertainment and the CDT, and Accountable, Responsible and Transparent AI. I think the future looks really exciting indeed for the center. Okay, so that's the end of my introduction. And so next, what we're going to be doing is moving on to talks from academics and industry partners, our external partners, in our 3 theme areas. And the first theme is going to be creative science and technology, and the speakers are going to be Neil Campbell and Dan Ring. So I will now relinquish control.
Hey Darren, thanks very much. Hopefully everyone can hear me now. It's a great pleasure to talk about the creative industry side of the research, and it's obviously not just me. It's my pleasure to present on behalf of all of my colleagues in the Camera Center. And so let's get started. As Darren mentioned, we're very honored at Camera to be able to work with so many exciting partners, and this has only increased in Camera 2, and we're still adding people all the time. So do get in touch if you'd like to work with us. Working with the partners and things like that is what enables us to do all these exciting things. And I'm going to sort of showcase a few examples from Camera 1 and projects that we've worked on. But I would really encourage everyone to follow the Camera Center on Twitter or look at the website. And on the website, there's Rebecca's very good at keeping up with the sort of news items and blog posts where we illustrate all the projects that have come across and then provide nice videos and background. And I think there's some interesting reading there if you want to see more than I'm just giving a brief overview today. So as the name suggests, motion capture research is always the core heart of how Camera came into being. And that's very much still a key part of what we've done today. And here's examples all the way across where we're looking at really getting these immersive experiences with digital characters and animation and rigging, and all of these things are very much at the heart of what Camera was created for and continues today. But it's also sort of extending, not just sort of beyond the capture, but also going into other areas such as perception and things like that. So what does it really mean to make someone to be someone real? Can we sort of down this course of digital humans, can we make things believable? Can we look at the psychology of interaction? There's the interaction of these characters in their virtual worlds. So some really nice projects here with Marshmallow Feast about what happens when you're sort of moving into VR. How do you interact still with or in AR? I always like my sort of I think there's some beautiful illustrations now of the motion capture research going away just from digital humans, and many will have heard of the project with the cats and dogs home on the campus, and seeing a whole range of canines coming through the studio, and really this kind of technology moving it to make it accessible. So it's not just from our big rigs, but now kind of looking at these sort of commodity sensors and things like that, and moving towards markerless motion capture and things like that. And that's really been an example of some success stories from Camera. And I think another thing that's nice to think about is that it's moved away from the incorporation of, we're not just looking at sort of motion capture technologies, but really the focus of the center can be more widely embodied with this kind of, how can we apply artificial intelligence and machine learning approaches in the creative industries? And we sort of include, as you've seen before in the motion capture, and I've talked about with the perceptions, it's a human focus on what we're trying to do here. So it's not just sort of mass automation of something like that. It's saying, how can AI and machine learning be used with putting people at the focus of it? So it's either users and artists, for example, in this project, and we'll see examples later where it's the audience or human. So there's always a human factor in here, and I think that's an underpinning theme. So in this project, as here with Smart Roto, this is a great example of where we really need to work with the partners, and we can achieve so much more than we would just sitting by ourselves and trying to come up with this. So here, working with the Foundry, providing their expertise on the VFX pipeline and understanding these tasks, and really great to work with DNEG. So congratulations out to DNEG, because they just won their recent Academy Award win for Best Visual Effects for Tenet. Here, they're providing access to artists, access to a massive training data set, so we can really test and check that these things work well in the real world. And Dan, I shall hang up in a minute, and Dan Ring from the Foundry will tell us more about how they're working on AI and ML in the VFX pipeline. It's a very exciting area, I think. And I'm mindful that when I started this, we did a user study right at the start of the project to sort of test this out, and it was a chance for us to really get to talk to artists and end users and people. And we sort of did this whole study and chatted to them. And they came back and I said, sort of, so how did you find it at the end? And everyone said, oh, it's not bad. It's quite interesting or something like that. And it's a bit demoralizing until the research team at the Foundry said that's the greatest praise they've ever had from artists. And I gave a talk in the US and tried to explain that it's in Britain. And so everyone understood, but there's really good feedback from end users when we try and do these things. And I think this is the right way of trying to automate, is to make tasks that work with artists rather than saying, oh, everyone's going to be replaced by machines or something like that. I think it's a really good story. And of course, this kind of technology is not just motion capture and these tools. Camera works across the whole range of the creative industry's tasks. And I think one of my colleagues, Mac's tasks, are really illustrative of that. So you go from hand pose estimation, where we're trying to do sort of markerless motion capture, which is sort of extensions of what we think as core mission, but also right back into sort of user interface. And here, trying to automatically design sort of abstractions of shapes and things like that are accessible and work with people, and some really cool and things that I would never have even thought of. So there's now these exciting creative tasks, such as here people are drawing and creating in the real world and in VR at the same time. So there's this pen which extrudes plastic as you go through, and you can be guided and create these shapes. So you're seeing them virtually as you create them, but you're also creating things in the real world. And really sort of this digital world, real world divide is being broken down here. And on that theme, it's great to see from my colleague Christian, now to the audience focus, how we can make really immersive VR experiences that people can use at home. So you saw there with the spinning selfie stick, that's just a standard camera on a selfie stick. And from that, you capture these amazing panoramas. And now OmniFocus is really working on visualizing, not just so it's sort of projected into a sphere world, but we're looking at as you're moving around your head, can you see the parallax? So you move your head around and you really feel that the screen is moving with you, you're feeling like you're there. And from someone who remembers putting on the early headsets and feeling very ill, and now I put on these headsets and you just get captured by really this real feeling of presence there. And it's great that this comes from just those sort of few photos. It's really making this kind of technology available to people at home. Darren's already said a bit about the studio, so we're really excited that new and great things are going to come from this. In particular, ideas such as virtual production and things like that that are at the forefront. And so that's a good link on then to Dan Ring. So I'll shut up and let's hear from Dan at the Foundry. So Dan, I think I've known since CVMP in 2011, and he's been the head of research now at Foundry, and has been at the forefront of leading lots of the technologies from camera tracking, optical flow, smart vectors, and now most recently, of course, the Foundry trailblazing the incorporation of AI and ML into the VFX pipeline, things like, and then we're going to hear about all of those, and I'll let Dan take over. And so take it away, Dan. Thanks very much.
Neil, thank you for that really glowing introduction. I wish my mom was here to have heard that as well. Great to see you all, and thank you all for having me. I was looking through the participants list and I see a lot of familiar faces. So like really good to see you all again virtually. And I do hope I get to see you again in real life, I suppose. So hi, I'm Dan Ring. As Neil said, I'm head of research at Foundry. And we've had the pleasure of working with both Darren, with Neil, the University of Bath, for a long time. And I'm really, really happy with everything that we've built together and all the conversations we've had. And I think that I'm going to touch on a lot of the key points that both Darren and Neil had mentioned, and kind of really call out why camera really fits, really serves its mission well. So if you haven't heard of Foundry, what is Foundry? We're essentially a software company that makes tools for post-production. So that's essentially every time, from when the director says cut and the images are captured, it's all the stuff that happens after that. So all the editing, VFX, color, everything that manipulates the pixel and delivers it to your screen. And we also do some stuff in pre-production, and also like storyboarding and story development as well. So, and we do bits and pieces in all of this, but which I'm going to touch on later, and why this is more of a a kind of a continuum and less of a kind of a discrete set of steps. But ultimately, you can think of us as largely around, like, say, the Photoshop for video in making the final pixel. So, if you just, I hate tooting our own horn, but to give you kind of a sense of like who we are and kind of our place in the industry is like essentially every film for best visual effects in the last 10 years more has been made using Foundry software, and similarly, like a high percentage of all the films that have won kind of the best picture have also been using our software. So I'd comfortably say that probably 95% of the things you'd see on Netflix or Amazon have gone through at least one bit of our software at some point. And the reason why I'm here today as well, and why this is important, is research has always been at Foundry's core. So everything from the beginning, from kind of our early, the work that we did at the very beginning, our early tools, kind of all stemmed from research. Were either kind of ideas from kind of college, from early kind of spin at things, and then all through the kind of Foundry's like trajectory. There's been a strong focus on research, and our research team has kind of grown kind of quite a lot over the years. And the key thing about this is it's not just sitting alone in the dark. This is always about kind of key collaborations, and it's like that's one of the things that kind of really rings true, and I think why we value kind of connections to camera and University of Bath so much. So what are we actually trying to solve? What are we, like in research, and what do we think of for the future? Now, we've all heard about kind of COVID and new normals and working from home and what that looks like. But from a creative industry perspective, things have changed quite a bit, and we kind of expect them to stay that way. Essentially, the amount of content that people want has skyrocketed, and there's no satiating anybody's appetites here. So you can see already like the amount of content on, say, Amazon and Disney and Netflix has hugely increased. Not only that, but like in the last couple of years, you've gone from just Netflix to having Apple, Disney, Netflix, Hulu, and a whole bunch of other things. And although cinema is still sort of, having a few wobbles at the moment, it is expected to kind of come back. And I think that the demand and the appetite for content is there. And what that means is essentially like if the number of artists in the world stays the same, and the number of the appetite has gone up. Essentially what that means is you have to work more efficiently. In order to deliver this, you need to kind of be more efficient at delivering at this volume, at this scale even. And then, but all the time while you're doing that, you need to make sure that your creative folks are being able to stay creative, that they're not just machines turning handles. And this balance is extremely difficult to hit. And I think this is kind of the crux of what we're trying to solve, and the kind of the guiding light for us. So how are we doing it? Well, I'm going to speak now on a couple of different kind of areas of technology that Neil has kind of already introduced, largely kind of around AI, but also kind of other things like virtual production and distributed cloud workflows. But I think the AI one is a good one that gives a kind of a very concrete example of like the difference between sort of, I suppose the difference between academia and industry, and then why the interface and that nexus point is so important to get right. So let me introduce you to Copycat. So Copycat is a recent tool that we've developed for our flagship product, Nuke. It's essentially a machine learning tool. And if you're familiar with machine learning tools, it's often typically you put an image in, you get something out, and then you're done. Now, if you're an artist and you wanted to get like a mask, say, so masking and roto are one of the kind of the hardest and most expensive parts of making any production. So it's where you want to separate your image into layers so that you can operate on each layer separately. This could be kind of a green screen idea. It could be just, say in this example, we have a jogger here and we want to kind of, blur out the background. We want to treat her differently, or grade her, like change her color differently than the background. So this is hard, and this takes a really, really long time. AI is typically sort of seen as a very good example of solving hard problems in a short amount of time. But the problem is that it's often with machine learning, if the thing that you get off the shelf doesn't work, there's very little you can do to kind of correct it. And often the time that it takes to correct an off-the-shelf solution can be prohibitive, and could be actually longer than it takes to just do it by hand from the beginning. So we created this tool called Copycat, which essentially allows you to put the power of machine learning into artist hands. So the idea is here is that you give it, like essentially, we're not saying, Copycat doesn't know anything in advance about what you're trying to do. You essentially give it pictures of what you have, like say on the left, like picture of the jogger, and a couple of images on the right. So you see this mask, feed it into Copycat and let it do its magic. And then it gives you back out a neural network model that can then do, or tries to do the thing that you've asked it to do. And then you can do that on the rest of your frames, or the rest of your shot, the rest of your sequence. So I'm going to show a very, very quick example of what I mean here. So this is Copycat in Nuke. And in this example, we want to segment, isolate this guy from the background. So it's about 300 frames. Now we pick 6 frames and we roto them. So I'm going to use the, if you haven't heard the word roto before, it's essentially manually isolating a kind of an object through kind of parametric curves. Now it's very hard. I'm sorry, I keep skipping on here. It's very hard to do well, and it takes a lot of time. And so in this case, we're just going to do 6 pictures. And then we feed those 6 pictures to Copycat. And what you're seeing here is Nuke in action. And you can see it is this kind of a contact sheet over here. And it's showing you what the network is trying to learn. Now, like as anybody who knows machine learning has done it before, it takes a while. So go have lunch, go have a long lunch, go have you know, a couple of desserts and a coffee. And then when you come back, you have a network that can segment the rest of your shot for you. So in this case, you can see here that it's done a pretty good job, that it's taken, I mean, it still needs a bit of work, but you've essentially got 300 frames done for, you know, essentially like maybe 20 minutes worth of work, maybe an hour's worth of work. And then, you know, you've also had a nice lunch. But this is essentially saved a huge amount of time. So if you think of like a 300 frame shot at this quality level could take days for an artist to roto correctly. And what we've essentially allowed people to do it is in a long lunch. Now, the more astute of you, this is as deep as technical as this is going to get. The more astute of you will realize, like, hey, you're just training on this one shot. There's hardly any data in here. You are overfitting. You are doing exactly what the literature says never to do. And so overfitting is essentially when you've trained a model to be too attuned to the data that you want. And it means that it can't generalize at all. Now, this is it. Like in all of the literature, it says overfitting is bad. You should never do it. But in a VFX world, the artist only cares about that one shot that they're given. They don't care about anything else. It never has to work for anything else. Well, generally, sometimes it might have to, but generally, they just want to get home. So they just want to do that shot as quickly as possible. So they only care about whether it works in their shot or not. So this is an example of the difference between sort of academia and research, and why it's so important to kind of understand what artists want. And this is, like, again, going back to Neil's point about, like, you know, always keeping the human in the loop. So let me show you some examples of what Copycat can do. So here's the jogger example, and this is like lots of frames. You can see here that the quality of the mask is a lot better than the previous one. And again, I think this is maybe only at 10 frames. Now, the cool thing about this that you don't get from a sort of an off-the-shelf kind of system is that compared to just a generic human mat that you might get from you know, a mask or CNN model or a pre-trained model off GitHub, is that it's also capturing her headphones. The artist has said, I want her headphones. I need her headphones. So, you know, when I draw my masks, I include that. And then that's what you get in the output. We also get some really, really nice things here, like around sort of digital beauty work. So here, if you look at her elbow, you can see that she's like really kind of badly grazed it. And this shot is actually really quite long. I think it's about 1,000 frames or so. And what's happened here is that we've just gone in and painted her elbow in about 6 frames. So again, hardly any frames, and just on her elbow. And let me go back here. So there's a close-up, and you can see that there's a lot of light changes. There's a lot of like movement. There's a lot of variance. There's different kinds of blur. Like there's a lot of things going on in this image, and Copycat is sort of able to kind of capture that. So this is, again, a really powerful tool, and this saves a huge amount of artist time, because this is a task where an artist wouldn't need to just like isolate an object, but they need to paint it out as well. And then here's our own Henry Cavill here having his beard removed. And so this is, again, a kind of a task which it takes a really, really long time to do this well. And I think this did take a lot longer to train. I think this is overnight, maybe a few more frames. But again, it went from being something that was nearly impossible to something that was achievable. Similarly with this, again, so this might be the last example. So this is a bruise removal. And again, a long shot, high res footage. And what it's done is, I think it's only been 2 patches where the bruise has been painted out. And it is kind of quite a subtle effect, but it's this kind of work, this kind of beauty work here is exactly the kind of work that, you know, that like every commercial has to have. Like the amount of beauty work that goes on to anybody who's like in a, you know, an ad or commercial is huge. It takes an incredible amount of time and paint and patience to do this. And in this case, we painted that, kind of like lightened his kind of bruise for 2 frames and then fed it into the network. And then very quickly we had a network that was able to remove the bruise in all of the other frames while still keeping the detail. So the key thing here is that I want to kind of hammer home is that this is about putting machine learning into the hands of artists' imagination. So this is not just creating a generic tool that is where you know, a handle is just turned and you automatically get you know, you have it all done for you. It comes down to being an artist. And the other thing is that this doesn't make you a better artist as well. So this is, again, humans in the loop is the key thing. It doesn't make you a better artist. If you're a bad artist, it'll just make you a bad artist faster. So that's the key thing, that this isn't about sort of replacing anybody's jobs or anything like that. It's just getting you to being more creative faster. So again, going back to this kind of scale and efficiency, but still remaining creative. So this brings us to the Smart Roto project. And Neil already kind of preempted this, and this is where we're really excited. Is as I said, masking is a hard problem, but we still have the problem that when copycat doesn't work, you still need to touch it up, and that's hard. It's still not a solved problem. Whereas Roto, on the other hand, as I mentioned before, is sort of a series of parametric splines. It gives you more control. So when it goes wrong, at least you can nudge it back in. And we fully believe that that's the future of where this needs to go. And again, the same principles, all about keeping the artist in the loop. It's all about like capturing every click, every gesture that the artist makes, ensuring that all of that is captured and kind of given back and fed back to the system. So it's building kind of a system that is not only knows what you're like, learns what you're trying to do, but is able to sort of improve over time. So this is incredibly important, and like all of our customers reckon that this is the most singular, valuable thing that we can do for them. It's also the hardest thing that we can do. We've been trying to crack this. So Foundry's been going for about 25 years. We've been trying to crack this for about 19 years, probably longer. And we're getting closer. I feel like we are getting closer, but it's still very hard. So what is Smart Roto trying to do? And so now that you're all wizards at knowing what masks are and you can judge quality, this is an example of what we're trying to do. Imagine you've got 2 frames and you want to isolate part of this guy's shirt. You pick 2 frames, so these are roughly 20 frames apart. You kind of draw your curves in 1 frame, you draw them in the second frame, and ideally what you want is the system to understand how everything has moved over time, and to kind of make sure that if we go to a frame in the middle, so you can see here at the bottom, that it should be roughly in the right place. Now this has been tried with just regular motion understanding and 2D motion, and that generally doesn't work very well. And what we are already seeing is, and this is like the results that we're still working on this, but I did want to show you this sort of result on the bottom right that shows kind of the difference between a ground truth example of what a real artist is given and what the system has achieved. And it's starting to get close, which we're really, really happy about. So this is that kind of wobbly outline on the right, even though it might look a little bit strange, we're extremely happy about it. And that represents a huge time saving for artists all over the world. So again, this is all about assisting artists and not replacing them, humans in the loop. The other things that we're looking at then are essentially like other technologies like real-time systems. And I think like if you've seen like virtual production, you know about like game engines, and you know about sort of what else, sort of like LED walls and kind of tools for allowing you to kind of be more creative faster and immediately. And what you're seeing here is our flagship product Nuke talking to Unreal natively. So it's able to liaise with Unreal and allow you to bring in pixels and generate pixels real time and bring them in. So one of the things that the challenges of the current industry is that tools are very often monolithic and very slow. And it means then that like if you're trying to build anything, it takes a really long time. So we're trying to look here at investigating kind of advanced workflows for speeding up and like to how you can get to seeing and working on your final pixel as soon as possible. And the idea being here with obviously with Unreal, it sort of feeds in then to virtual production. So we're very keen on virtual production. I think it's like one of the things that I think is very impressive about the camera work is already seeing the new stage, particularly within Film Studio Bottle Yard, which is fantastic. I think like this virtual production work is it's incredibly interesting. It's revolutionizing the like how things are made. And while there are kind of a lot of really good examples of like tentpole examples like Mandalorian being used here, there's so many other examples of being used in commercials, in episodic work for everything. And I think it's sort of one of the more exciting technologies or advances in filmmaking that we've seen since green screen. And I think it's the next sort of natural evolution of it. And we're very keen on sort of understanding, and it's a huge area to explore as well, like ripe for research. And we're very keen to kind of get stuck into it. And this is the kind of the next sort of nexus point of where we think that like academia and research and academia and industry kind of really need to partner on to kind of make the most of it and bring that out of the sort of the emerging technologies kind of section to this is just the way we make films and TV now. And then tying that back, then we're already starting to see how we can applying machine learning to solve some of these virtual production problems. And so this is again sort of going back to the copycat thing, is where because you no longer have green screens, it's very hard to kind of create these maps automatically. So then things like we really need to look at machine learning. And this is just one example of solving a masking problem with machine learning. But I think there's like the lovely thing about new technologies like virtual production is that it raises a whole host of new challenges and new problems. Like I said, all ripe for research. So that's a very big kind of whistle-stop tour of kind of like Foundry and also kind of our thinking on like the value of kind of bridging that gap between academia research and this sort of like the fabulous applied work that Camera is doing and more importantly, keeping people in the loop. Thank you all very much. I'm going to hand you back to Darren.
Thanks, Dan, and thanks, Neil. That was really fantastic, and it's going to be really exciting I know that we've kind of got these kind of deep links, these things like smart roto, so I'm really looking forward to, and I think hitting nail on the head, it's not just about mocap, or it's not just about, as Neil said at the start, it's about AI and actually, like kind of like looking at these, like how can we like look at all these different tasks and look at how things like AI and visual computing and and mocap can like help to solve these problems, solve problems in this area. So really looking forward to carrying on working with you guys. It's going to be amazing. And so on to the next. So the next theme, we're going to be looking at human performance enhancement, and we have Steffi Collier and we have Danny Holcroft from the BBSA, and they're going to talk about some super interesting work in this theme. So over to Steffi.
Thanks, Darren. Hopefully everyone can hear me and see my slide. Good morning, everyone, and thank you for joining the launch event today. As Darren said, my name is Dr. Steffi Collier. I'm a lecturer in biomechanics within the Department for Health and a co-investigator of Camera. And I have the pleasure of taking you through some of the exciting projects we've been working on and plan to build upon within the human performance enhancement theme. I'm also thrilled to introduce Danny Holcroft, who's the Head of Performance Innovation and Applied Research at the British Bobsleigh and Skeleton Association, who are one of the key partners within this theme. And we'll hear from Danny a little later on. So within this theme, you'll be unsurprised to hear that we are interested in improving human performance. And this spans physical, cognitive or perceptual performance. Actually, in many cases, we're interested in understanding both. And the performance applications we apply our research to are wide-ranging, from elite sports performance to developing effective forms of training simulations in virtual reality, to improve work task performance in potentially high-pressured situations, and to adapting multisensory perception to improve the performance of amateur athletes with more of a focus on healthy living. And within this theme, our key research areas are therefore performance or movement assessment, and the investigation of multisensory perception and attention. And these projects require quite a unique mix of researchers within CAMRA, with varying areas of expertise, allowing us to innovate across computer vision, AI, and biomechanics, utilising technologies such as motion analysis, virtual reality, augmented reality, which you'll see in the example projects I go on to talk about. And as it should become clear across the theme presentations today, several areas of these are cross-cutting, particularly with the digital health and assistive technology theme that will be presented shortly by Professor James Bilson. So in my next few slides, I'm going to give you a bit of a whistle-stop tour on some of the exciting projects that fall within this theme. And we'll also hear from Danny about how our work aligns with the BBSA's goals. So the first area of interest I'd like to highlight is a project being conducted by Nikos Haralabidis, a PhD student within CAMRA, who's utilising a complex computational approach to model an elite sprinter and explore strategies that they can adopt to improve their performance. Of course, this is within realistic physical, physiological and biomechanical constraints. And within this research, we utilise marker-based motion analysis to try to capture the movement of the underlying skeleton. And you may be able to see some markers in the videos that are playing now, which have been very carefully placed on relevant anatomical landmarks. And this is quite a lengthy process. Additionally, we measure the ground reaction forces and the activity of muscles to better understand how the performance is achieved. However, using purely these experimental approaches, it's very difficult to suggest how someone could actually improve. And so utilising a detailed musculoskeletal model of the athlete and a sophisticated optimal control approach, we're able to very closely replicate how the individual performed during the captured trial, which is a very important step in the modelling process, and then utilise this framework to run predictive simulations to see how this athlete could adapt their technique to improve their performance. And this is the first study of its kind adopting such an approach in sprinting. And although it's ongoing, the initial results are really exciting in this field. So the next strand I'd like to present to you is our Markerless motion analysis work, which combines CAMRA research expertise across biomechanics and computer vision, hence the project title biocy. And you saw in the previous video how we can utilise marker-based technologies to assess human movement. But within computer vision, there are automatic pose estimation algorithms, which have been developed to try to extract the human pose information from normal images without the need to place markers. And this is of great interest to the biomechanics community because it could free us from the lab and eliminate the need to carefully place those markers on the participants and use the specialised cameras. And theoretically, this will allow movement data to be collected using a normal video camera in a wider range of settings than is currently possible. So a number of algorithms, a few are provided on the right-hand side, have been developed on the computer vision side, typically for applications in entertainment and gaming. And these algorithms automatically detect a set of sparse points in the body. So for example, a person's joints. And these are used to model a skeleton of connected segments. However, so far, the accuracy of these has not been fully evaluated against marker-based motion capture, which is widely considered to be our gold standard, although it does have its own limitations. And the biocy project really seeks to assess how close we can get to those ground truth data. And whilst our evaluations are also ongoing, you can see in the video the resulting human skeletons that these algorithms output. And on the right-hand side, you can see a comparison between the motion captured using the marker-based system and the same model driven by the markerless results. And this close match here is really promising, and these videos really provide us with a glimpse into how the future of biomechanics is likely to look. So at this point, I would like to pass over to Danny Holcroft from the BBSA, one of the key partners within this stream of work. Thanks, Danny.
Thanks, Steffi, and thanks for having me on. Just a short little bit from me, really, just to get a bit of context. Those who don't know skeleton, we're a Winter Olympic sport. We're a Winter Olympic sport. Sorry, I have a few computer issues in the background here, so apologies if I disappear or cut out. Yeah, well, we're a Winter Olympic sport. Head first down an ice track, about 2 kilometers in length. We hit speeds of about 145 kilometers an hour, up to G-force of 5, and we drop down gradients of about 20% head first with no brakes. So as a short context to us as a sport, a bit of a crazy sport. Next slide, Steffi, please. And a bit about what we try and do. We're a high performance program funded to deliver success, but we're very much about creating opportunities for people to be better and to fundamentally deliver performance. That's our job. And we're about chasing something we deem as achieving the impossible. So we take 18 to 20-year-olds who've not necessarily been in high performance sport before, certainly haven't been on a skeleton sled, and then we look to turn them around in 4 or 5 years and put them on top of the Olympic podium. In terms, with that in mind, what we've achieved as a sport in the UK, we've been very, very successful. So we've been in 6 Olympic Games since we got reintroduced in 2002, and we've won 7 medals. And we had 3 Olympic champions in the last 3 Winter Olympic Games. So what we try and do is successful, and long may it continue, and CAMRA is a massive part of that. And fundamentally, part of the reason why CAMRA works for us so well is the way we've achieved it is that as a sport, to put a bit of context, is we have no facilities in the UK. So we spend 120 minutes per year on ice doing our actual sport. So just a couple of hours. So that's 8 hours in an Olympic cycle. So we have 8 hours on ice to deliver Olympic gold medal winning runs across 4 years. So with that, we've got a real clear vision and a strategy that we work to. And part of that is accepting that we have to be better and we have to evolve, and we can't sit in a traditional way of doing things. So once we've been successful and won a gold medal, for example, we can't just repeat that. We've got to go looking for the next edge. So we've got a very developed, innovative mindset of questioning and challenging, and identifying what those key questions are that we want to answer. Which come to the question of why CAMRA, and like I said, it's unique for us because as part of our sport, we have a running aspect at the top of the track, and it's very hard in the facilities that we have on tour to get any decent analytical footage of the running aspect, and therefore it becomes hard for us to really find the actual small detail that might take us to the next level. And the question we had going back 5 years was to try and explore this a bit more and go away from conventional CAMRA methods and doing what we've done for the previous 10 years. And CAMRA was the exciting mechanism to try and help us explore that question and hopefully give us some answers. And Steffi may come into it in a little bit, that we are in a very, very good place moving forwards. And on that short snapshot from me, I'll hand back to Steffi, who will give a bit more context to some of the work.
Thanks very much, Danny. Thank you. It actually provides a really nice segue into the next work package I'd like to discuss. So as Danny mentioned, we've been conducting a number of projects with the BBSA over the years to try to provide them with useful information to impact the training and performance of their athletes. And similar to the previous biocy project that I introduced, we're developing and validating methods to be able to capture relevant performance information in their normal training environments here on the University of Bath campus. So this involves similar methodologies to those I introduced previously, whereby we are extracting information about the position and the orientation of the athlete's body from video. In this case, we have a specific interest in understanding how an athlete develops velocity across the push start or during other more conventional sprint-based activities. And we've also recently been developing software to allow this information to be captured, processed and fed back, and therefore utilised much more readily by the coaches and the support team. And our hope is that this information is very useful for them in the upcoming major competitions that they're preparing for. So thank you, Danny. Okay, oh, sorry, there's a bit of a delay there. I'll just head back. Okay, so swiftly transporting you from Bath to outer space for the next project. This project is being conducted in partnership with the European Space Agency, with the aim to essentially better understand the load experienced during prolonged periods of hypergravity. So musculoskeletal tissues such as bones, muscles and tendons are mechanosensitive, meaning that if they're not loaded sufficiently, they will experience detrimental adaptations, and they require a certain level of load to maintain, for example, bone mineral density or muscle mass. So for this reason, when astronauts return back to Earth, they typically have compromised musculoskeletal function. And this project, which is being conducted by our PhD student, James Coburn, looks to understand the internal, so the joint and muscle loading, experienced under varying levels of hypergravity, utilising a similar musculoskeletal modelling approach, that which I introduced with the sprinting study earlier. So such information can be used to inform the design of, for example, exercise countermeasures that astronauts can perform when in space to sufficiently load their musculoskeletal tissues to better maintain their function and performance. Additionally, this project looks to understand how the design of such countermeasures, for example, the gravity replacement treadmill that you see in the video, how that can better replicate Earth loading in partial gravity and provide the required stimulus to maintain homeostasis of those relevant structures. Okay, the last two slides relate to creating more realistic immersive environments to improve physical performance outputs. So for example, when exercising in virtual reality. So on the top left, you see a study whereby the researchers motivated people to cycle harder by self-competition in virtual reality. So showing them their previous performance as a ghost avatar, and then making it harder for them to catch up with themselves. So making the ghost perform better, which is referred to as feed forward. This proved to be a very powerful and motivational tool, which has very promising implications for exercise performance and therefore health. And James will further discuss the application of this to exercise rehabilitation in the next presentation as well. On the top right, people's ability to run and jump has been virtually augmented in a virtual reality exogame, allowing them to run faster, jump higher than they can in real life. So this increases their motivation, and it also can make exercise more accessible for people with disabilities. The bottom left image involves exploring how avatars affect people's performance when exercising in virtual reality. And actually, interestingly, the exaggerated fit avatar, so figure C that you see on the screen, was less effective than the more realistic avatars, so figure B, at motivating the people when exercising in VR. On the bottom right, camera researchers have used machine learning and motion capture data to train virtual sword fighting avatars to behave and react in much more realistic ways, improving the immersive experience and therefore kind of the performance during virtual reality gaming. So the final related stream of research focuses on using virtual environments to predict where people look in an environment and why. So this work incorporates virtual environments and virtual reality with potential applications for augmented and mixed reality. So the video here shows eye tracking in a real environment, but it's very hard to test specific theories without greater control over what is actually seen. So camera researchers have presented a new way to track eye gaze in three-dimensional interactive virtual environments and examine where people pay attention in an environment as a function of the task they're given. So that is to look freely at whatever they wish, to find a specific object, or to navigate from one point to another. And they found that the task predicted where people looked, and how a computational map of salient visual features can be improved to better predict those eye tracking results. And so this is an important step in the design of virtual environments for human interaction in a multitude of applications where training or performing tasks in immersive environments could have an important role. That's all I have time for today, but thank you for your attention. Thank you for Danny for contributing to the session as well, and for giving me the opportunity to showcase some of the fantastic work that's been ongoing within this theme and will continue to go on within this theme. We have a number of partners on board already who you can see on the screen, and we hope to continue to co-create some really exciting and interesting projects across the course of Camera 2.0. Thank you for your time. Thank you for listening.
Thank you, Steffi, and thank you, Danny. I think it's really like, I think this is for us. I think going to be, you know, we put a lot of groundwork in. I think in the last 5 years in developing, you know, to getting us to the stage where, you know, we're in the wild and you know, we're doing this kind of analysis. Just, you know, thinking back to the kind of elite sport applications. And, you know, we're at the stage now where it's kind of like, how do we get this into the coach's hands as well? So, you know, we have a project where we're essentially saying, okay, I think this is part of the research into impact transition that we're trying to do in camera. You know, we're now at the stage where we're kind of saying, okay, how do you get this prototype software now into a coach's hands so they can use it whenever they want? So, you know, we're creating like kind of web-based interfaces now to use the underlying algorithms for doing this kind of analysis on people. And I think then, you know, Skeleton are kind of they're the pioneers for us in terms of like the project partners here. But, you know, what we're going to be doing is like really going deep and working with them, and then seeing how we can, you know, how we can impact other sports and other applications. And so thanks, Steffi, and thanks, Danny. And that leads me nicely on, I think, as well to the last theme. Apologies a little bit, we're not keeping right to time, but hopefully you can stay with us to the end. And my wrap up won't be 10 minutes, it'll be quite short. So the final theme for today, we're going to talk about is digital health and assistive technologies, and we have James Bilson, University of Bath, and Russ Kopak from the Ministry of Defence, and I'll hand you over to James.
Thank you very much, Darren, for the introduction, and welcome everybody. And I'm going to talk to you about our digital health and assistive technology theme. And there's been some really nice introductory material, which means there are certain things which I don't have to go into today. For those that don't know me, I'm a professor of human and applied physiology, but most of my work is really focused on clinical rehabilitation and looking at the biological and mechanical basis for improving human function. And when Darren approached me in 2014 to come on board as a co-applicant and co-director of Camera, I really did go along to this meeting thinking, I'm not sure what's in this for me, but I'm so pleased that I went along to that meeting, because the resources that Camera has brought along, the relationships which it has enabled, and the multidisciplinary research projects which we've got off the ground as a consequence have been truly transformative. And I'm going to try and share some of that with you today. And I'm obviously speaking on behalf of a lot of colleagues who are working very hard behind the scenes. This is not me trying to take glory for their efforts at all, but just to represent the highlights of our current and planned research activities. Obviously, within this theme, we have a number of clinical partners, and this is not meant to be exhaustive in any way. We're very open to new partners, but we're currently working very closely with colleagues at Salisbury NHS Foundation Trust, of course, the Royal United Hospital in Bath, our colleagues at the Great Western Hospital in Swindon, and a number of commercial partners, and we've been very well supported by Qualisys and more recently by Living With, and I'll talk about some of the relationships and partnerships which are allowing us to move forward on certain projects with those partners. And one of our key partners has always been the Ministry of Defence, and particularly the Defence Medical Rehabilitation Centre. And when I finish my presentation, I will hand over and introduce my good friend and colleague, Russ Kopak from the Academic Department of Military Rehabilitation, who is working closely with us and helping to take some of this work forward into truly transformative applications. I always like to see my research on some kind of translational pathway and with an end goal in sight to resolve real world problems and challenges, and that's exactly what our partnership with these organisations enables. I'm going to talk to you about 4 key work packages within this theme. This is not meant to be exhaustive. There's other work going on, but these are 4 of the key work packages which we're currently engaged in. Steph has given a really nice introduction to virtual reality exergaming. I'm going to talk about some of our applications within the clinical and health environment. I'm going to talk to you about some of the ways in which we're integrating clinical imaging and assessment techniques to improve patient treatment pathways. I'm going to talk to you about a really advanced project where we've developed an app for knee osteoarthritis users and have plans to take that forward into other clinical conditions. And I'm going to finish by talking about clinical gait analysis and this markerless motion capture technology that we're developing and evolving, because that could be truly transformative for clinical care, and that's the project which I'll then hand over to Russ to talk a bit more about. So they're the 4 key work packages, so let's get started. As I said, Steffi's already introduced virtual reality exergaming and talked about it in a performance context. But of course, performance means lots of different things to lots of different people. And in terms of a rehabilitation context, if you can provide something which is truly engaging and motivational to someone who's on a rehabilitation care pathway, that can be truly transformative in terms of their function. It can speed up the rehabilitation recovery pathway and process, and ultimately get them back to an even better physical functioning condition and a health status than they were previously. One of the things we've done with this exergaming platform is we've transformed it for upper body exercise, and you'll see one of my PhD students in the bottom right there engaged in this high intensity interval training session with his VR headset on. He's just going through the low intensity warm-up phase, and at the end of this countdown he'll move into the high intensity sprint phase, and that's when the intensity changes. He's chasing his previous performance there, and of course we have numerous ways of manipulating that previous performance to enhance motivation, enjoyment and engagement. There's a long way to go. This is not perfect. We've got lots of things that we want to try out in terms of making the avatars more realistic, making the number of levels that people can go through to maintain their motivation during rehabilitation and recovery. But what we have done is very early on is looked at a number of key parameters which might be predictive of not only engagement in the activity, but their long-term adherence to these kinds of treatments. And you can see that compared to a blank screen, once we start to engage people in exergaming, putting them in the track mode where they can see their previous performances, it improves enjoyment of the activity, and that seems to be maintained throughout. What was really interesting to us was not just the ghost avatar enhancing enjoyment, but actually even when we surreptitiously increase the resistance by 10%, getting them to work harder, they still maintain this high level of enjoyment in the exergaming activity. So there's lots of potential applications for this. Like other colleagues have said, this is now about getting it into the hands in a cheap, cost-effective way so that people can use it and engage with it in lots of different rehabilitation environments. Moving on to clinical imaging and assessment, we've had a long-standing interest in lower limb amputees, and at the start of our project, one of the things we were really keen to do was try and improve the personalization, and you'll keep hearing that word crop up throughout my presentation. All of the work packages I'm going to talk about today are largely about improving the personalization of care, and that's really important in terms of getting these things right, making treatments more sensitive and more personalized for, in this case, the improvement of fit, the improvement of comfort. One of the problems with lower limb prosthetics is the wear and tear on the stump or the residuum, and so one of the things we've done is use this imaging technique to give ourselves really realistic images of the lower limb residuum, so that we can start to think about how we personalize things like socket fittings and liner fittings for the lower limb prosthetic devices. You can see that we started by just using models of prosthetic limbs. We were then able to create mesh images that we could put into CAD type technologies. We were then able to measure within those sockets where the peak pressures occurred and where that leads to degradation of skin tissue over time. And what we've done now is we've worked with our colleagues in engineering to allow us to use those CAD images, which are a direct image of the residuum of the individual, to, in very quick time, cryogenically machine prosthetic liners, so that they are a really good fit for the individual. We've done some initial user testing, and the feedback is tremendous. Of course, what this means is, because this is relatively quick and cheap, is that we can reproduce these over time as the residuum changes in shape and volume, to ensure that the prosthetic user has a really good fit of their prosthetic device. We've also used imaging and assessment with colleagues from the Royal National Hospital for Rheumatic Disease, who have a lot of specialist clinical knowledge and know-how in terms of the treatment of ankylosing spondylitis. Apologies for that. And you can see on the left-hand side where we've used wearable sensors, and we're trying to look at the alignment of the spine. Of course, this is something that's very difficult to do, because where's your point of reference? But by putting these markers at key vertebrae, we're able to look at the relative changes in spinal curvature as this degenerative disease progresses. So the clinicians can have some more objective evidence of how the disease is progressing over time and why the individual might be feeling the symptoms that they are over time. And related to that, on the right-hand side, my colleague has been integrating various technologies using relatively cheap 3D ultrasound imaging to create 3D images of the spinal column, so that again we can take a really unique approach here to looking at how this disease is progressing and changing over time to improve the care pathways of individuals. And of course, that allows us a research tool to say, well, if we start trying different kinds of interventions now to slow down the progression of this disease, we've got some objective measures of how that's affecting the spinal curvature and degradation over time. The next area which I wanted to talk about was the development of health apps, and this project was led by my colleague in computer science, Dr. Simon Jones. We received funding partly from the centre which I direct, the Centre for Sport Exercise and Osteoarthritis Research, and a very close partnership with Versus Arthritis, the charity. Some funding from the Fast Healthcare Network Plus scheme, and a collaboration with Professor Nikki Walsh at the University of West of England in Bristol. And we were keen to really take an empirical approach to this to get this right from the start. So we followed the clinical guidelines. We looked at the users and we interviewed the users, and we also interviewed physios. And then we engaged that group of people through the development and feedback process using think aloud interview sessions and again physiotherapy feedback about how the product was evolving and developing. And we're just entering into a 3-week user experience trial now, and going to be working with Versus Arthritis to get this out to a larger and more diverse community of users over time. Here's a very short video of the Intelligent Knee Osteoarthritis Lifestyle app, and really what we're seeking to do here is to integrate a range of important facets which doesn't currently exist. This is again very novel. There are apps already out there to take people on a very short-term journey to improve the strength and mobility of their joints. But what this does is look to do that, but also then take them on a journey in terms of maintaining a physically active lifestyle to continue to enhance their condition. They can tailor their own exercise choices. The app learns about them and their preferences. It only gives them options for the sorts of activities that they've said they want to engage in, whether they be indoor or outdoor activities. It gives them activity guides and instructional material on how best to perform activities. It gives them local opportunities and lets them know how they can engage. And it also provides us a means of social interaction, something which was seen to be very important by the people that we interviewed, creating local communities of practice, people with similar conditions that they can relate to, and hopefully enhance their motivation to sustain this over time. We're now looking to take this into, we've got this Android model, we're looking to take this into an iOS model, and we're now working with a commercial partner to take this out to market so that you can get to the maximum number of users. So I'm going to shortcut that one there because I know we're running a little bit short on time. I'm going to finish off by talking about our work on Markerless clinical gait analysis. And Steffi's already shown you something similar to this by looking at our pose estimation algorithms and training those over time. We're now in this very fortunate position where we can track human gait quite accurately in healthy individuals. But of course, for our purpose, we want to be able to track movement in individuals that often have prosthetic limbs. And you can see this individual walking here. And if you look at the right limb of this individual with the light green limb as it's coloured on your screens, you can see that as the legs cross over, it loses the ability to track the ankle and the foot. And that seems to be quite random at the moment because it's struggling to pick up some of the reference points in this below knee prosthetic user. That problem seems to be further exacerbated when we look at an above knee amputee, and you can see the dark blue limb, the left limb of this individual, and the knee joint is jumping up and down. It's struggling to track the knee joint because it doesn't exist in this individual, and of course that also gives us the same problem of tracking the ankle, foot, and the remainder of that prosthetic limb. So we've still got some work to do in improving these open pose algorithms for our clinical applications. But ultimately, the purpose of all of this work is to reduce the time taken currently with putting markers on people, doing a lot of post-assessment processing to try and get the kind of biomechanical characteristics that we need to know about, so that we can get this into the hands of clinicians and make this much more accessible and much more usable to give instantaneous feedback on the lower limb biomechanics of a range of clinical users to inform clinical decision making. So on that note, I'm now going to hand over to my colleague, Russ Kopak. I've always enjoyed working with Russ. We've known each other since around 2002. He's an empiricist at heart, and so he believes in evidence-based practice in clinical rehabilitation, and he's now the clinical research manager at the Academic Department of Military Rehabilitation and the Defence Medical Rehabilitation Centre. A few years ago now moved from its previous home at Headley Court to a new purpose-built facility which you see here at Stanford Hall in the Midlands. So over to you, Russ. Thank you.
Oh, okay. I don't know if anyone can hear me.
Yeah, we've got you.
You have. Good. Okay. Hello, everybody. As James said, my name is Russ Kopak, and I'm the Clinical Research Manager on the Academic Department of Military Rehabilitation at the Defence Medical Rehabilitation Centre at Stanford Hall. My department, we provide a central hub for clinical research activity, not just here at Stanford Hall, where I'm talking to you from today, but across the entire defence rehabilitation community, which involves 14 regional rehabilitation units and hundreds of primary care rehabilitation facilities at unit level. So it's a relatively large organisation, both in the United Kingdom and overseas. I'm only going to talk over this one slide because I've just been asked to give a very brief overview. And we thought it would be useful to provide some background in how we currently use 3D motion capture technology to inform and shape our patient treatment programs, and how the camera project, how we may be able to plug into that development and how it can augment and build upon our approach, particularly to biomechanical assessment of our patients. So to give you some background into treatment, I think that's important because it provides a context to why we use biomechanical and 3D motion capture assessment in the way that we do. So here at Stanford Hall, we have a 300-bed inpatient treatment centre that delivers multidisciplinary team trauma, neurological and musculoskeletal rehabilitation to injured military personnel, particularly musculoskeletal injury. The treatment of MSKI, as we call it, is the highest research priority for the Defence Medical Services, and that very much shapes and informs our priorities for research and explains why we deliver the studies that we do. So every patient that we see will enter a best practice care pathway. James mentioned the fact that we try and adopt an evidence base for the treatment that we deliver to our patients where an evidence base exists. But one of the phenomena that we've seen over a period of time, but we're particularly aware of it in recent times since the campaigns in Afghanistan and Iraq, is that we will have two patients who may have the same baseline characteristics, they will have the same demographics, they will have the same diagnostic injury type, they will have the same mechanism for injury, and they will enter a care pathway at the same point, and they will essentially be subject to the same treatment. But what we often observe is that those same two patients, one of them will recover more fully and quicker than another. And the inescapable truth is that we don't really know the reasons why, but it's increasingly believed that one of the reasons may be an artifact to their biomechanics, a disruption to their biomechanics. And that one of those patients will receive the corrective training to address that biomechanical dysfunction, but more by serendipity and the skill and the art of the therapist, whereas the other will not have received that optimal corrective training. So for all of our patients now, particularly those with a musculoskeletal injury, restoring, inverted commas, normal biomechanics and addressing biomechanical dysfunction is a goal of treatment for every patient. But we can only achieve that goal optimally if we have access to the technology that will allow us to assess biomechanics, the biomechanical disruption, biomechanical movement patterns with a certain amount of accuracy and precision. Now here at DMRC, here at Stanford Hall, we're quite well served. So in my department, for example, we have a very large biomechanics performance lab, 30 meters in length by 15 meters. We have a 34 3D motion camera system, 16 floor mounted force plates and other technology, which means that we can accurately assess biomechanics in this environment. And there are three programs I just particularly want to mention very quickly, which we think may have an application moving forwards in part 2 of the CAMERA project. The first is what we refer to as the BIOPS surveillance project. BIOPS stands for biomechanical patient screening. So every patient who's going through a musculoskeletal injury program here at Stanford Hall will attend for biomechanical screening in our biomechanics performance lab. They will undertake a series of planned functional tasks. And these movement patterns are being stratified into clusters. And what we're doing is examining these clusters of movement pattern and associating them with clinical outcomes. In other words, is there a particular movement pattern that is associated with a good outcome of treatment? And are there certain other biomechanical presentations which are associated with a less satisfactory outcome of rehabilitation? The key for this is it allows us to use biomechanical assessment and 3D motion capture technology as a basis for targeted treatment goals. And actually, we think that's the holy grail for the clinical application of 3D motion capture, is that we can, its primary application in the MOD up until this point has very much been lab-based, informing research questions. We're now in that translational period where we're very much looking for this 3D motion capture to actually inform the patient's treatment, probably a little bit more than it does at present. We have another major program with our trauma amputees, monitoring the biomechanical changes at 3-yearly intervals over a period of 20 years. And this is a nested study as part of our advanced study cohort. Very quickly, the advanced study is a 20-year prospective observational study monitoring the long-term complications and outcomes in our battle casualties, our trauma casualties who were injured in Afghanistan and in Iraq. And the third program is we are looking at the utility of virtual reality in rehabilitation and virtual reality therapy. So we now have access to a computer-assisted rehabilitation environment. Some of the delegates may be aware of that technology, but in essence, it's a virtual reality trainer. And we are trying to augment the data that we are collecting using our Karen system to come up with some machine learning and artificial intelligence algorithms that will reinforce diagnosis with some of our patients. Why is that key? Because unless you have an accurate differential diagnosis, you can't marry that to an evidence-based treatment program, and you probably won't reach your treatment goals as early as we and the patient would want to do. And the whole basis underpinning defense rehabilitation is to accelerate the process and get the patients back into their primary role, their operational role, in the shortest possible time. So anything that can give us a competitive advantage in reinforcing diagnosis is something that we're interested in. And the application of machine learning and artificial intelligence is something that we haven't really explored with any degree of seriousness in the past. And it's something that we currently, we have a PhD student who's investigating that, the whole utility of AI and machine learning using virtual reality. So just to finish off and bring it back to the camera technology, I just want to pick up on something that Steffi said earlier. She talked about taking biomechanics out of the lab and into the wild. And we think there may be some real utility in the unobtrusive data capture methods that the camera system may provide, but not for necessarily for use here at DMRC. I mentioned the fact that we have 14 regional rehabilitation units and hundreds of primary care rehabilitation facilities. We have a clamour for accessible, user-friendly, validated systems which minimise patient burden at those establishments. And it's quite possible that the camera Markerless system may provide a solution to this need for these unobtrusive data capture methods, which is why we retain an interest in partnering with Bath and with the camera team. We think it's a fabulous project, and we definitely see some utility to the way in which we deliver rehabilitation within defence, and may well provide a technological solution to some of the real world clinical challenges that we experience, and hopefully may provide some betterment. So we look forward with breathless excitement to seeing how it develops in the next 5 years, and thank you very much for your time. I don't know who I'm handing back to.
I rush back to me.
Oh, hi, Darren.
For the final time. Yeah. Thank you, James. Thank you, Russ, for that, and thank you everyone for staying with us. I think we've overrun a little bit, but I think that's just because of the enthusiasm of what we've been trying to talk about, and the speakers, and so hopefully everyone's really enjoyed. And just to kind of circle back a bit again, I think this is one of the short-term goals of the next 5 years. We've already put in a lot of the groundwork on the algorithms for things like Markerless analysis, motion capture, and one of the things that we need to do is that validation to make sure that this technology is up to standard, right? It's the same as the gold standard, and that's what we've been putting on. So all that validation work, all the hard work and validation which we've been doing, and we have a prototype system for doing this analysis, and the thing now is essentially that engineering and validation to make this into essentially a product which can be used and rolled out across sports, health, rehabilitation, and so I'm really looking forward to, I think, the next 12 months where we really kind of are really accelerating that phase of the project. So yeah, so more on that as we move forward. So I just want to finish off. Again, thank you for everyone for attending. Thank you to all the speakers today, all the partners for giving their time up, and all the participants, the attendees for giving up their time. So I won't be very long now. I just want to wrap up. And I think if you want the short version of the wrap up, then please just look at the bottom of this current slide. So this is the how to get in touch. And if you want to get in touch with us, we have a website. Please follow us on social media. Sign up to our newsletter. The direct contact is our center manager, Rebecca Hole. And if you go to our camera website as well, there's a getting in touch mechanism as well. I hope you've enjoyed the launch event, and I hope you've enjoyed finding out about what we've been doing the last 5 years and what we want to do for the next 5 years. Please reach out to us. I want to again draw people's attention to how we can work together. We're open to research collaborations, and we have ways of supporting research collaborations. So we have there are things like PhDs, there are things like postdoctoral time that we can match, but it's all about collaboration. But it's also not just about this, right? We also want to work together in terms of using our facilities, the training that we're going to provide, do things like workshops. Please, this is one of the major parts of the impact for Camera 2 is democratization of technology. It's taking things like motion capture. Russ doesn't have to wait 10 years, right, to buy a product which is solving this problem. We're working on it together now, and we're delivering it now, right, with partners. And that's what being a partner is. It's developing prototypes and getting them into the wild early, and that's what we want to do. So we really want to democratize camera, and there are different ways we can do that through our training, through our facilities. So please reach out and get in touch. What's happening next on the agenda for us? Well, there are going to be events which are coming up in each of our themes, which are going to be coming up this year, and there are going to be, and then we're going to be having other types of networking events and workshops. So please keep your eyes open for announcements on these events, and they're going to be happening soon. And keep an eye open as well for opportunities to access funding and for specific collaborations. So that's it. I think again I want to thank everyone for attending. I draw everyone's attention to the getting in touch. Please follow our website, sign up to our newsletter, follow us on social media, or get in touch with Rebecca. Even if it's speculative, let's work together to see how we can kind of create impact and kind of maximize research. So on that note, thank you very much. Thank you for attending, and I think that's the end of the launch event. Thanks.